Numerical number 13. A car travels with a uniform velocity of 25 meters per second for 5 seconds. So let's try to draw that. A car travels, we're going to label this, it goes from A to B with a uniform velocity of 25 meters per second for time equals to 5 seconds. The brakes are then applied and the car is uniformly retarded and comes to rest in further 10 seconds. So from here, from point B, we are applying brakes and the car comes to rest at point C. So we can say at point C, final velocity equals to 0 and the time taken from B to C to come to rest after applying the brakes is 10 seconds. This is all the information given to us. Now let's see what we have to find. The first thing is the distance which the car travels from before the brakes are applied. That means we have to find what is the displacement from A to B. So let's try to find what is the displacement from A to B. Displacement equals to, okay, so first of all, we know velocity equals to displacement upon time. So displacement equals to velocity multiplied by time. So displacement equals to, now remember, velocity from A to B is 25 meters per second multiplied by the time from A to B, it takes 5 seconds. So multiplied by 5, which is equal to 125 meters. So this is our first answer. The displacement from A to B is 25 meters per 25 meters. So, okay, now let's go to the second part, the retardation. Now, when we are talking about the retardation, we are talking from point B to point C. So at point, now we are only considering what happens to the motion from point B to point C. So at point B, our initial velocity, as you all can see, our initial velocity will become 25 meters per second. And our final velocity is 0 and the time taken is 10 seconds. So by our formula for motion, V equals to U plus AT, acceleration A equals to V minus U divided by time t. Now final velocity is 0. So 0 minus initial velocity is 25 and the time taken after the brakes are applied is 10 seconds. So divided by 10. So acceleration equals to minus 2.5 meters per second square. Now there are two ways you can write this. You can say acceleration equals to minus 2.5 meters per second square, or you can also say retardation equals to 2.5 meters per second square. Now let's look at the third part. The distance traveled by the car after the brakes are applied. So we have to find what is the displacement from B to C. We have to find the displacement from B to C. Okay, so the formula to find the displacement is S equals to UT plus half AT square. So let's try to put that formula. S equals to UT plus half AT square. So S equals to initial velocity is 25. So 25 multiplied by time, which is 10 seconds, plus half. Acceleration is minus 2.5. Remember, it is retardation. So minus 2.5 multiplied by time square. Time is equal to 10 seconds. here time equals to 10 seconds, so 10 square equals to 100. So S equals to 250. Now to remove this decimal, we have to put a 10 in the bottom. So 0 and 0 cancel, 2 ones are 2 and 2 fives are. So 25 times 5 is 125. Minus will be the sign now because plus and minus will become minus. So S equals to 125 meters. So after the brakes are applied, the car will travel 125 meters and come to rest.